Okay, class, good afternoon, everyone. For today's class, we will talk about annuity. So this topic is related to the last one that we discussed last time, which is about simple interest and compound interest. However, this is more related to the compound interest, particularly the A pin that I mentioned to you last time, and more particularly about the I and the N, because we will use the I and the N here. What is I again? I is the periodic interest rate, right? We call it the periodic interest rate. And then we have N, which is the number of periods. Okay, class? Okay, as what we have been doing for the past week, we always start with keywords and key phrases. And again, we divide this into two parts. Part one has to do with the present value. So that's one of our keywords and key phrases, present value. And then part two is future value, which we denote as FB. Okay, and the other one we denote it as PV. Under present value, we will talk of the of annuities. Okay, of annuities, and these are the annuity due. Okay, ordinary annuity. I'm sorry. Okay. So anyway, ordinary annuity. Okay, that's why we denote it as OA, ordinary annuity, and then the annuity due AD. Okay. Similarly, for part two, we will also tackle this too: the ordinary annuity and the annuity due. Okay. But this time, our focus is more on the future value. Okay. That is why we can talk of a present value of ordinary annuity. So that's why we can say this is in acronym. We can call it the PVOA. PVOA. Present value of ordinary annuity. Okay. And then present value of the annuity due. So PVAD. PVAD. Now, when in part two, similarly, so we have ordinary annuity also and annuity due. So if we use acronym to remember this concept, so we can have FB, right? So FBAD for the annuity due, FBAD, future value of annuity due. Then if it's future value of ordinary annuity, FBOA. Okay, I'm mentioning this to you because later on I will use these terms. Okay, I will use this what's this acronym. Okay, class. So now, so again, I mentioned that annuity is focused on the payment. If last time we focused on the A, which is the total amount to be paid or the interest earned when you borrow that principal, okay, then principal plus the interest, P plus I is equal to capital A, right? Total amount to be paid. Here, our focus is how to pay the capital A. How will you pay the capital A? Okay, so that's what we will focus here. And then remember in A, for example, 1 year. For example, 1 year, you borrow this amount P, then you will pay it in 1 year. Then you'll do it in installment. For example, you borrow this P from the bank. So, and then you'll do installment monthly. So how many periods do you have in 1 year? So remember the N. N is the number of periods, right? So MT. So M is 12, right? Because it's monthly. And then T is the number of years. Now T here is 1. So 12 times 1 is 12. So the number of periods is 12. Okay? So we have 12 periods. And then you plan to pay the A in 12 periods. So these periods can change, class, huh? But in this example that I gave you, the period is monthly. So you will pay the A monthly. Now, if your period is semi-annually, so that means every 6 months. But still possible 12 periods, right? 12 periods. Every 6 months. So 6 times 12, 72 months. So we're talking of 6 years, right? Okay. So what I'm trying to say is that the period is not always monthly. Okay. But since in an example, it is 1 year and then monthly. So we have, we pay the bank every month for 1 year, Okay. So how do you do that? So the capital A, you divide by 12. Capital A divided by 12. So in general, capital A divided by M, right? You get your periodic payment, which we denote as R, capital R. Periodic payment. So we call it periodic payment. But in this example, we call it monthly payment, right? But again, if it's semi-annual, Semi-annual. So semi-annual payment. If it's quarterly payment. If it's quarterly payment, you pay the bank every 3 months. If it's semi-annually payment, you pay the bank every 6 months. But however, in our example, it is monthly payment. So we pay the bank every month for 1 year because our T in our example is 1 year. Okay, class? That's why we just talk in here. I will just talk in general, every period. Okay, I just want to emphasize to you that the period may mean different. It depends on the problem. It can be monthly, semi-annually, quarterly, and so on and so forth. In our example, it's monthly. So you will for you to know the R, the capital R, you divide A, the capital A by 12, or in general, capital A by M. There, you will know. Okay. So now, for example, you won a lottery, right? You won a lottery, and then you want to pay it now. You don't want to pay. You don't want to do the installment anymore, but you already applied in the bank. Already applied. So what will you do? So you want to pay now. So you will go to the bank and mention that you want to pay now. So the bank will tell you that it's possible. So what they will do, they will compute the present value, which is our lesson today, right? The part 1, present value. So instead of paying the A, the capital A, which is greater than the P, the principal which you borrowed, you will pay present value, which is between P and A. So it's greater than the principal, of course, but less than the capital A. Okay, but again, but still there's an interest. But again, but at least it's not A, it's not the capital A. Okay, so that's the idea here, class, because these things happen, right? These things happen that you want to pay immediately. You don't want to think of the monthly payment anymore. But the others, they will do the monthly payment because they plan to use it for the business. That's okay also. No, that's fine also. They use they will do, not that they don't have the money, but they will do that maybe more. It's more practical for them because they have a business and they want to use it for the business. That's why they borrow from the bank. And they know that the interest that they will earn from the bank, from that business, is greater than the interest you earn from the bank. So it's also practical. So it depends on the business. Hopefully the business will go well, right? So there's a risk. So anyway, so at the end of this module, you're expected to understand the concept of simple annuity. So I gave you a little concept already. Identify different kinds of annuities. So I mentioned already 2, but there are like three kinds. But there are 2 major classifications of annuities. But we'll focus only on one classification, which I will discuss to you later. So the kinds that I mentioned are the ordinary annuity, remember, which we denote as OA, and then the annuity due, which we denote as AD. Sometimes annuity due is called immediate annuity. You will know later why. It has to do with the payment, immediate payment. You pay immediately, something like that. So we'll understand this better. So we'll focus on those 2. But there are other kinds of annuities. But we also tackle them, but just one problem, but not so much. We don't focus on that so much. No? And then we solve problems involving annuities, this present value and future values of these annuities, the ordinary annuity, the annuity due, and the other one, which we call the deferred annuity. Okay? But again, we will focus on the 2 only. But we'll tackle just one problem, I guess, for the deferred annuity, and only the present value, because we can also talk of future value of deferred annuity. That's why if annuity due is AD, we can say deferred annuity DA, okay? The acronym for that. So if we have a present value of deferred annuity, so we can say present value PB, PV, PVDA, PVDA. But we don't have FBDA because we will not talk of future value of deferred annuity. But there is a topic like that, but we will not tackle that. Okay, so now let's focus more on annuity. So as I mentioned, it's a payment. As I mentioned, it's a periodic payment. So we can denote the periodic payment as capital R. Okay, so more about it. So it's a sequence of equal payments made at equal periods. So the periods may be what? May be done annually, semi-annually, and so on and so forth. So I believe you have an idea of this annually, semi-annually, which we denote as M, right? Because we use that in compound interest, the A pin, okay, for the compound interest. Because to get the I, you have to know the M, right? This M, to get the N, you have to know the M also. And it has to do with the annually, semi-annually, etc. Okay? Now, some good examples are monthly payments of rent, weekly wages, and annual premiums on life insurance. So I mentioned the life insurance already, right? And the credit card. Okay? For this one, payments of rent, for example, rent of the house, if you're renting a house, I don't know, it depends on the owner of the house. So for example, usually you pay monthly, right? You pay monthly. So maybe some owners, they need the money. Okay, they will have an agreement with you. Okay, you can pay for 12 months. It will be lower. because the owner will get the present value of your monthly payments. Okay, so there is a total, right? For example, for 1 year, for example, your monthly payment is R, right? R. That's your monthly payment, periodic payment, R. So times 12, so you have 12R. Okay, so then the owner talks to you if you can, because he or she needs money. Can you pay now the 12 monthly payments? Then it will be less than 12R, something like that. So it depends on you. It depends on the one renting the house. Okay, I also do that. Okay, in my case, I do that. Okay, I also do that. I pay in advance so that my payment from the rental of the house is less than the total. So I also do that. Okay. But very rare, because sometimes I prefer monthly, so that instead of paying you this amount, I can use it for business. Okay, something like that. So that's an example. Then I also give you example for the credit card, right? And the insurance. So now, what are the types of, or the classification of annuities? So you can classify into two: annuity certain and contingent annuity. But our focus is more on this. Okay, let me read. Annuity certain is the one which payment begin and end at fixed times. So it has to do with when do you begin the payment? It's the end of the term or at the beginning of the term. That's what it says here. The annuity is certain. Okay. The contingent annuity, it's one whose payment depend on an event that cannot be foretold accurately. I won't focus on this because so that you won't lose the focus. This is focus on this one. So this one, as I've mentioned, there are different kinds, and there are three kinds. So I already mentioned to you the kinds. So we have ordinary annuity, annuity due, deferred annuity. But we'll focus more on the ordinary and annuity. But we'll tackle one problem probably here, particularly present value of deferred annuity. For this two, we'll talk about present value and future value. No? So okay, let's discuss this. Ordinary annuity is the payment done at the end of the term. Annuity due payment is done at the beginning of the term. That's why your definition of annuity is what? It has to do with payment begin and end at fixed time, something like that. So because it's included in the kinds of annuity. And the deferred annuity, the payment is doesn't begin at the beginning, neither at the end of the period. You notice period. So when you say period, it can be monthly, semi-annually. So very general. We use the general term here. Okay, so we talk here of periodic payment. So what's the meaning of this? So for example, class, monthly. So let's talk of 1 year. Okay, 1 year, and then monthly payment. So how many months do you have in a year? So 12. So in effect, you have 12 periods. Okay, 12 periods. So this period can be monthly, or in general can be semi-annually, and so on and so forth. But for now, let's talk of monthly. But the what I will explain will be applicable to other M's. If it could be applicable to semi-annually, or even annually or quarterly. But this one is monthly. So for example, you will pay now your monthly payments. So you have, let's say you have 0. So let's denote it at 0. And then 1, the dates of payment, your dates of payment. Okay. So 0, 1, 2, 3, and so on until the 12. So 0 to 1, that's your period 1. 1 to 2, that's your period 2. So until you reach the 12th period. What is your 12th period? 11 to 12. So let us say these are the, you divide the what do you call this? The 1 year into 12 periods. Okay, into 12 periods. It can be, okay, let's say January 1, like that. January 1 to probably January 31, like that. So that's 0, 0, 2, something like that. And then let us say the second period is February 1 to February, depends, 28 or 29. So that is your 1 to 2, 1 to 2. Okay, so that's the thing, 0, 1, 2, 3, 4, and so on and so forth. So for example, this one, the payment is done at the end of the term. So meaning to say, you pay instead of paying at 0, you pay at 1, like that. That's the meaning of ordinary annuity. So since 12 payments, when will you end the 12th payment? On the 12th. Okay, because there are 12 payments, 0, 1, 2, 3 until the 12th. So if you start at 1, not at 0, when will you end the 12 payments? Of course, at the 12th. Maybe December, end of December, something like that. Okay, annuity due, the payment is done at the beginning of the term. So meaning to say, you pay immediately at 0. So at 0. So when will you end the payment? Of course, 11, because there are 12 payments, right? 11 plus 0 is not the 0 of 0 number, because 11 plus 0 is 11. I'm talking about the the date, something that has to do with the dates. Okay, for example, this date is denoted as 0. Okay, and then the other date is denoted as 1, something like that. So for the annuity due, that's why this is also called immediate annuity, because you pay immediately. The annuity, that's the meaning of annuity due. You pay immediately at the beginning. So still 12 payments, both of them 12 payments, but different. The start of the first payment different. Okay, class, you understand the concept of ordinary annuity, annuity due. Now, let me give example. For example, the ordinary annuity. For example, credit card payment, right? The credit card, you always pay at the end of the term. You borrow the money now from the bank, and then you apply for installment, but you will pay after a month, because usually if you apply for the monthly, for example, but if it's semi-annually, the installment semi-annually, you will pay the bank every 6 months. If it's quarterly, every 3 months. But since our example is monthly, so every month, that's where you will pay. You will make the first payment at the end of the first month. Okay? Whereas annuity due, you have to pay immediately. So what's an example of that? When you rent a house, class, di ba? When you rent a house, you pay immediately. When you rent a house, you pay immediately. So that is the example of annuity due. Okay? So for example, you start now. So you pay January, for example, January 1. And then you just want one year for your contract for the rental of the house. When will be your last payment for 12 payments? Because it's monthly. December 1. That's your last payment, December 1. Something like that. But for the bank, it will be December 31. Something like that. If for example, you start also, you borrow money from, or you borrow the P. Remember, that's the principal. You borrow this value of P from the bank, January 1. Okay, so you will pay probably January 31, like that. So if it's 12 payments, your last payment, your first payment will be January 31. So your last payment will be December 31, right? Okay, so that's the idea. That's the difference between ordinary and annuity due. It depends. So this one you pay immediately. This one you pay later. But of course, the later is meaning it depends on the M. If your M is semi-annually, after 6 months, okay, you will pay after 6 months, something like that. Okay. For the annuity due, you pay immediately at 0. And then since also semi-annually, when will be the next payment? After 6 months, the second payment after 6 months, but the first payment at 0. Then after 6 months, the second payment. Whereas here, there's no payment at the beginning. So the first payment is after 6 months, if it is semi-annually. Since our example is monthly, that's why I mentioned about after 1 month. Okay, class? So I think it's clear now the difference between ordinary and annuity due. Now we will talk of present value. You will notice that the present value of ordinary annuity, or rather the annuity due, is greater than the ordinary annuity. Later, you will observe that. Because this one, you pay immediately. The earlier, the better, right? The earlier you start, the better. That's why the present value is higher than this. Or even the future value of annuity due is higher than the ordinary annuity. So it's like the insurance class, right? If you start earlier, the higher, right? But of course, it depends on the number. Let us say the same number of years, and the same monthly also, monthly payment. All conditions are the same except the payment. One insurance is ordinary annuity, the other insurance and annuity due. So of course, this one will yield higher than the ordinary annuity because this one you pay earlier, you pay immediately. Okay, so it will earn a lot of interest, something like that. So anyway, a deferred annuity, you pay between, not really the middle, but between. You defer it. You defer the payment. Okay. You don't start at the beginning. You don't start at the end of the term. Sometimes you have to wait for like 5 years, and then you start the payment after 5 years, something like that. I think it's usually for investment class. So you will do the monthly, right? Something like that. Okay, after like 5 years. So anyway, so let's discuss. You'll understand this better in the example. So let's start with okay, there. You have the formula immediately, right? That's why at the beginning, I already cited to you some mnemonic device so that you won't be, I'm preparing you for these formulas. Okay, so this is the PIVOA. PIVOA, what do you call this? PIVOA, because ordinary annuity, right? PIVOA. And then this the PVAD because this one is annuity due. Now again, we're talking of present value. The only difference between the two is that this one, since ordinary annuity, you make the payment at the end of the term. This one at the beginning of the term. By the way, class, replace A here by R, capital R. Remember I told you, you might get confused because we also have capital A. Capital A refers to what? Total amount to be paid, as we talk in compound interest. And then the R has to do with the periodic payment. Okay, so please replace A here by R. Okay, so now let me show you the Excel file so that, by the way, class, this one, replace this. This is the one I mentioned. Replace this by this because these are the same. This is the same except that there is a 1 plus I. You notice? There is a 1 plus I. Because in the Excel file, I use this. So here, I also use this except that I multiply it by 1 plus I. That's why the relationship between the two, you can think of this as PVAD is equal to PVOA times A plus I. So let me write that very fast. So PVAD, okay, I was not able to write it before the class. So PVAD, okay, I'm sorry. I'm not used to this one, especially if it's on the spot. Okay, I'm sorry. So anyway, that's PVAD class, okay, is equal to, that's why I want to write it ahead. PVOA. Anyway, I'm saying it, so I think you can understand. PVOA. Okay, PVOA. That's PVOA times 1 plus I. Okay, that's what I mean. 1 plus I. 1 plus I. So anyway, that's 1 plus I. So that's why this one, when you simplify this, you will get this actually. Okay, so let me erase it. It doesn't look nice. Eraser. Yeah, eraser pen. There, erase. Okay, now let me show you the Excel file so that you will remember it well. Okay, this is what I mentioned to you right before. PVOA RIN. Okay, so why PVOA RIN? So remember the present value of ordinary annuity. This one is PVAD RIN. This one is present value of annuity due. What is the RIN here? What is the 3 and the 4? Okay, the RIN class is the one given in the formula. This is R, this is I, this is N. Because if you're given the problem and then you want to know the PVOA, you have to find the R, the I, and the N in the problem. Something like that. That's why, and then the 3, you have 3 I's. 1, 2, 3. Of course, I know you have 2 I's, okay? But what I mean is the I, the letter I. 1, 2, 3. So 3 I. But actually, you don't have to remember that. I'm just giving you some for you to remember the concept, okay, or understand the concept. Now this one is PVAD RIN because to compute for PVAD you have to find the R, the I, and the N. But here you have 4 I's, okay, 4 I's because I replaced this by this. How many I do you have here? 3. But you multiply by this, so you have 4 I's. But if you wish to stick to this, the I is still 3. But again, it's easier if you have the same, right? This one is the same as this. And besides, when I use it in the Excel file, I can just copy paste. Oh, look at that. I copy paste only. But you notice there's like a 1 plus I because we will use this in the problem later. So what I'm saying, class, is this. That's why it's important that you remember PVOA RIN and PVAD RIN because it has to do with this. Later on, you will just put the values of the R, the I, and the N. And then once you have those, you just plug in. You will get the result. Then look at this. This is the formula. I just put it here. Customize. I know you know how to do this because I taught you how to do this when we discussed about simple interest and compound interest. Now, if you want to repeat the formula, I also taught you that, right? Copy paste, then you will have it here. Now, for this one, it will be easier. I just copy paste the formula here and then add this, the 1 plus I. You notice? Oh, there. The 1 plus H3 because it's customized. But I did not type this again. I just copy what is here. I just put it here, copy, and then I added this part. Okay? So that's why it's easier. And it will be faster. All we have to do in the problem, identify the R, the I, the N. You can get the PVAD. But remember, I told you already the interpretation of you know already what's present value because I discussed that to you already. And you know already the relationship between the two because I told you this is higher. You will, for example, the same R, the same I, the same N. You will have here the same R, the same, like this one, or the same, what's this? There, 550,000, 0.05, 0.0510, same. 50,000, but you notice the PVAD is always higher than the PVOA. Why? Because this one, you pay immediately. The payment is big. Remember, if it's annuity due, you start the payment at the beginning of the term. And also because of the presence of 1 plus I. 1 plus I is greater than 1. So if you multiply something by greater than 1, of course it will be, and considering this is the same, right? Remember I told you P bad is equal to P VOA times 1 plus I. So meaning to say, this really will become great. By the formula itself, it tells you that this is greater than the PVOA. By the concept, it also tells you that PVAT is greater than PVOA because you pay immediately. The earlier, the better, especially in the interest, right, for the business. The earlier, the higher your interest, something like that. But of course, if it's a loan, there's the problem, right? You don't want, if you borrow money, you want a lower interest. So anyway, now let's do the problem. I don't think we'll be able to finish this. At least we were able to finish one problem. Okay, a man paid 10% down payment of 200,000 for a house and lot and agreed to pay the remaining balance on monthly installments for 60 months. At an interest rate of 15% compounded monthly, compute the amount of the monthly payments. So it looks complicated, right? But how, since you understood already the concept, so I believe it's not complicated to you. So it's like this, class. So 10% down payment. So meaning to say, what's 10% of 200,000? Oh, okay. So 10% is 0.1, right? 0.1 times 200,000 is 20,000. So you will pay that 20,000. So what's the remaining balance? 180,000. So you want to do installment for the 180,000. For how long? 60 months. 60 months is what? 5 years, right? Because 60 divided by 12. So in other words, every month you will pay for 5 years. So question is, how much will you pay monthly? That's the question here. And then the interest rate is 15%. This is the J class. This is the J. Remember I told you, a monthly is the M. The M here is the 12. So if you want to get the I, divide only. Can you divide this? 0.15 divided by 12. What will you get? So here, class, what will we get? We will get the, it's still connected to compound interest. We will get the capital A. So let's go back to capital A, the A pin. So let's go back to A pin. Where's the A pin? A pin is here, okay? So what we want is find P, I, and N, okay, class? And then we will solve for A. Okay, we will solve for A. So what's the principal? 180,000. I think I solve it here, or here, 180,000. So what is your I? 0.0125, class. Remember I told you divide. Divide 0.15 by 12. Remember, I is equal to J over M. So 0.15 divided by 12, if you compute it, you will get 0.0125. And then the N is already given. You don't have to compute it, 60 periods. But if you want to compute it, MT, right? 12 times the number of years. But it's already computed for us, so 60. Now, you look at the answer. What's the total after 5 years? That's the total A. Now, how will you pay this monthly? 379,292. So the interest is kind of big, right? If you want to get the interest, subtract this 2. Now, but the question is not the interest. The question is the monthly payment, the R, the capital R. How will you get the R? Here. Divide. Logically, it will. What will you do? Divide this by this. Now, look at the formula. I'm sorry. Oh, there, diba? So divide this, the highlighted, divide this by 60. Okay, this is the formula, and you will get this. Okay, class? So that's the answer to this problem. Where's the problem again? So compute the amount of the monthly payment. So that's the answer. In fact, there's a space, but see, we did not use the space anymore because I already showed to you how to use the Excel file, right? So just input the values. Where's that? 180,000, this one, this, and then you will get the A. To get the R, divide the A by the N. You will get the R. That's how easy it is. Now, how will you connect the annuity, class? How will you connect the annuity here? Probably I'll discuss this next time, but just to give you an idea, to connect it to annuity, I'm sorry, not this one. To connect it to annuity, class, so for example, you don't want to pay anymore the monthly installment. You don't want to do that anymore. So what you'll do, you have the money already to pay. But the money that you will pay, as I mentioned to you, is the present value. So expect that the present value is between 180,000 and 379,292.64. Okay, so that you don't have any more monthly obligation. So how will you compute that? So that's where the PVOA RIN will come into the picture. So there, where's PVOA RIN? So this one. Actually, I got it here. Oh, there. So what is your periodic payment? So I think I can discuss that now. So this one, remember, This is the periodic payment. So this is the I, this is the N. You notice this is your PBOA. Isn't it less than? Did you see it, class? 265,723. It's between 180,000 and what? And the 379,000 here. Oh, see, did you get the idea now? So that means this is the present value. Oh, isn't it easy, class? Once you know the formula, all you have to do, just plug in this. This one you computed, and then you get the present value of the ordinary annuity, class. Okay, I think I will end there so that next time we'll continue to other problems. Again, this is another example. No? This is another problem on the ordinary annuity. Okay, still ordinary annuity. But I think I will end here, class. So I'll discuss more next meeting. So, because we still have classes after this, right? So we only have like 5 minutes before we go to our next class. So thank you very much for attending class. So bye for now.